this lesson is find the closest point to y in the subspace W spanned by V1, V2. So here's y, V1, V2. Same procedure again, just this time we are asking the closest point to y. Okay, so first we need to do orthogonal. So V1 times V2, 3 times 1, 1 times negative 1, 1 times negative 1 times 1, and then 1 times negative 1 is over here, and that gives me 0. And since it is 0, then it is orthogonal. Next, we need to do y v1, 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 y v2, v2, v2. Okay, so same procedure, but this is the first part of the orthogonal decomposition theorem. So y v1, 3 times 3, 1 times 1, 5 times negative 1, 1 times 1, that gives me 6. Next, y v2, 3 times 1, 1 times negative 1, 5 times 1, 1 times negative 1, and that gives me 6. Next, v1 and v1, so 3 times 3, 1 times 1, negative 1 times negative 1, 1 times 1 gives me 12. Next, v2 and v2, so 1 times 1, negative 1 times negative 1, 1 times 1, negative 1 times negative 1 gives me 4. After that, we just plug them in accordingly. Okay, so y v1, 6, v1 v1 is 12. This is v1. Next, y1 v2, y1 v2, 6, v2 v2 gives me 4 here, and this is v2. Simplify, this is reduce, this gives me 1 over 2. Reduce gives me 3 over 2. Multiply across gives me this vector and this vector. Okay, so one more time. Reduce, 1 over 2. Reduce, 3 over 2. Multiply, multiply gives me this vector and this vector. So 1/2, multiply this, which gives me this. 3 over 2 times this will gives me this. After that, just add across, and since the denominator are the same, 3 plus 3 gives me 6, divide by 2, 3. 1 subtract 3 gives me negative 2, divide by 2 gives me negative 1. Negative 1 plus 3 gives me 2, 2 divided by 2 gives me positive 1. 1 subtract 3 gives me negative 2, negative 2 divided by 2 gives me negative 1. So by the best approximation theorem, y hat, which is this is y hat, and see how it is written right here, y hat is equal to the projection of W to y, okay, onto W span V1, V2 is the closest point to y in W. So this answer right here is the closest point to y in W. And what is y? Y is this up here. This is y. And this is what we're looking for. We are looking for y hat, which is this. This is y hat. This is the closest point to this y. One more time. Y hat, which is this. This right here is y hat. Again, this is y hat, which is the closest point to y, which is this. So again, this is y hat. This is y hat. So this vector is the closest point to this vector right here. Okay, so y hat is the closest point to the regular y in W. Okay, so that's what I wrote down here. By the best approximation theorem, y hat is the closest point to regular y in W. Okay, so one more time. This is y hat, which is the closest point to this y in W. And that's what we are looking for, the closest point.